Hello everyone, uh, I'm Kunal, and today I'm gonna tell and explain you about the stock market prediction using the Python and machine learning. So, introduction: what is exactly stock market prediction? Stock market prediction is the act of trying to determine the future values of company stock or others. Stock market prediction is basically defined as trying to determine the stock value and offer a robust idea for the people to know and predict the market and stock prices. It's generally presented using the quarterly financial ratio using the data set. The use of machine learning and artificial intelligence technology to predict the price of stock is an increasing trend. Objective: what is the objective of this project? The main objective of this project is to find the best model to predict the value of a stock market. During the process of considering various techniques and variables that must be taken into account, we find out that techniques like random forecast, support vector machine were not exploited fully. In this paper, we are going to present and review a more feasible method to predict the stock movement with higher accuracy. This project also presents a machine learning model to predict the longevity of the stock in a competitive market. The successful prediction of the stock will be a great asset for the stock market institution and will provide a real life. Now, what are the steps we perform to implement it? The first thing we have to take into account is the data set of the stock market prices from the previous year. The dataset was pre-processed and turned up for the real analysis. Hence, our project will also focus on data processing of the raw dataset. Secondly, after processing the data, we will review the use of random forecast support vector machines on the dataset and the outcome it generates. So, and in addition, the proposed project examines the use of prediction system in real world setting and issues associated with the accuracy of overall values given. So what is the system architecture? First, we will take raw data, then feature extraction. Then we will split data into two, which is training data and testing data. Then after that, we train data result and also testing data. We get a trained data result, and after that, we get a predicted stock price in a final result. So what are the module identification? Data collection. Firstly, data collection is a very basic module and the initial step towards the project. It is generally deals with the collection of the right data set. The data set is to be used in the market prediction and has to be filtered based on the various aspects. Data collection also complements to the enhance the data set by adding more data than are external. Our data mainly consists of the previous year prices. Okay. Now second, which is the pre-processing. Data pre-processing is a part of data mining which involves the transformation of raw data into a more coherent format. Raw data is usually inconsistent or incomplete and usually contains many errors. The data processing involves checking out the missing values and looking for a categorical value, splitting the data set into training and test set, and finally do a scaling to limit the range of variables so that they can be comprised on the common environments. Now, third, the training machine. The training machine is similar to feeding the data to the algorithm to touch up the test data. The training sets are used to tune and fit the models. The test sets are untouched as a module should not be just on the bias on based on unseen data. Hence, it is divided into ratio of 80 and 20, where 80% is for the training set, and the rest 20 is for the testing set of the data. Now, what is data scoring? Data scoring. Fourth, the process of applying a predictable model to a set of data is referred to as scoring of the data. The technique used to process the data set is the random forecast algorithm. Random forecast involves an assemble method which is usually used for the clarification and as well as regression. The authentication system control is implemented to make sure that only the authorized entries are access the result. So further, when we implement the code, we will see that we will perform these basic these four steps in that. And so let us see the code that we implement in Jupyter notebooks. So let us see the code. So first step, what we will do, load the dependencies, import pandas as PDs. Panda is a software library which is written for Python programming language for data manipulation and analysis. Import NumPy as NP. So what is NumPy provides a large set of numerical data types that you can use to construct an array. From sklearn.model selection, import train test, we will split the data into training and a testing method. From sklearn linear model, import linear regression. We will use the linear regression to predict to find out the to predict the stock prices. So I'm going to use the linear regression method. Linear regression basically is to try to plot the best filling for the graph for those values which we will take from the data set. Now from sklearn, import matrix, import matplotlib dot pyplot as plt. This is basically for use for this is a plotting framework which is used in basically for graph to implement or plot the values in the graph. Plots dot style bmh style. Now second, style dot use ggplot. We will basically plot style, use a style to plot it. Now second, this actually this is I had not shown you the data. Let me just show you the data. I have load the data and store the data into data frame, which is df is equal to pd.cscav. I had taken a data set from online, which is says the it is the previous year sale of Tesla cars, and I just show you the this. So this is the CSV file I'm talking about. So this is the data set of date, open, close, open price, high price, low price, close, and adjacent close volume. So these are the different data in app. Now we will again go to the code. Now we will I had load the data and store the data into data frame. Df is equal to pd dot read slash csv tesla dot csv. This is my file which I just show you. So now next I am gonna print the data frame with the head of this with the column value 25. So you can see from these are the 25 value which have the date, open, open price, high price, low price, close price, and adjust price. So we're gonna use this parameter and also the volume. So now next. So I have taken a two variable which is x is equal to df high, open, low, volume, and their values, and y which is df is equal to close dot values. Now I'm gonna split the data into two, which is test and training data and testing data. So testing data I have 0.2, which is 20%, and rest remaining is for the training data, which is equal to 80%. So testing data is 20%. Now I've used a variable which is regressor, which is so I had previously told you that I am using linear regression to predict the value. So I have used the regressor variable and equal to linear regression. Now regressor dot fit x train and y train, these are the these are the values x and y. So I have trained x and y. Now output is this. So next what we do next, y is equal to predict regressor dot predict x test. So result is equal to pd dot frame data frame actual y test flatten and predicted y, because I'm using close, because I'm using close basically close price for the prediction of the data. So now result I'm using again head with 25 input columns. Now these are these as you see these there are two column actual and predicted. So these are the values, these are almost like same 395, almost same, uh, actual and predicted. So you can see that these are the 25 values of actual and predicted. Okay, what this is actual value and this is predicted value. Now next, so I'm import math graph is equal to result dot head 20. We show 20 result of a 20 in graph. Now graph dot plot, I'm using kind, which is kind is equal to bar graph. I'm taking which kind of a graph it is. It is a bar graph. So this is the you can see this is the values. Oh, sorry, this is the graph. You can see that these are the actual in red and blue. These are the predicted. Okay. Now, so I'm gonna show you these predicted data and actual data into basically two graphs. First, this which I showed just you, which is a bar graph. Now, next I'm gonna show you in a line graph, which is more used more analytic way to show more details about it. So next, I'm gonna use some variable mode, more variable. So firstly, I'm taking the number of trading days, which is a df dot shape. So output is 252 and 7. Now I'm going to visualize the close price data. So I'm going to plot figure. Figure is equal to 16 by 18. Plot title, which is Tesla, and X label in X label. I'm going taking days, and in Y labels I'm taking a close price in dollars, and plotting the graph, which is data frame I'm using, that which is the close wise, and I'm gonna plot and show them. So You can see these are the close price values. Okay, now again I'm gonna take a close price for the four head ahead. This is not used. So I'm going to create a variable. This is create a variable to predict x days out of into future equal to 25, and df is equal to prediction, df is equal to close, and shift into the futures day, and df is dot tail 4, which then this is showing a close price and prediction, which is currently not showing, which is not in numbers on none. So now next, we're gonna create the feature of data set X and convert into a numpy array and remove the last X rows and days. So we use X is equal to np dot array df dot drop prediction future days and print X. So these the value we print the values of X is print. Now create the target next is to create the target data set y and convert into, first we do in x, now we do in y, which is for the we use uh, convert it into a numpy array and get all the target value except the last x days. Y is equal to np dot array df prediction, which is future days print y. So all these values of the y which we are printing of prediction of the future days we want to print and show. Now next, again I'm going to split the data into this is in 80%, 80% and 20%. So this is 20. So x train and x test data, train data. So y train, y test, which is equal to train test split x y test, which is testing data is equal to 20%. Now get the last x or rows of the feature the data set. We're gonna x get the x rows of the feature data set. So x future is equal to df dot drop prediction, and futures is x column future is equal to x future tail, and x future is equal to np dot array x future. So we're gonna these values of x in array in the forms of array we printed in printing this. Okay, so basically we are use this for for the future prediction. So we are getting the y and we y which I split into two, which is equal to high x is equal to high close and close, and second which is y which is equal to close price, and x is equal to sorry high price close price high price adjacent price and volume. So basically we are on the futures day we are I'm on the splitting the first x future and same for the y. So now I'm gonna create the model, the create the decision tree regression model. So lr is equal to I'm initializing a variable lr which is equal to linear regression fit, and which is same x train and y train. Now show the model linear regression prediction. lr prediction is equal to lr dot predict x future, which these are the values and set. Okay, 1 minute. Okay, x future and print lr prediction. So these are the values which we will get. Now in the end we're going to visualize the data. Prediction is equal to lr prediction. When I'm using variable which is for validation, which is valid, which is equal to df x, which uses x dot shape, and valid again it's gonna valid prediction, which is equal to prediction, and plot the figure. Fixed size is equal to 16 by 18, and plot the title, again the model of the car, which that had the model, or a specific model you can say, and plot x label into days, and y label which is close price into US dollar, and plot again close and I'm gonna validate both plotting in this plotting plot, which is close and prediction. And then I'm gonna show, and there is three value which is come in the end, which is the original value or the validate value, or which is the actual value, and last which is the prediction value. And then now plot show, which is show, and we're gonna see the output. What's the output? Okay, so this is the output you can see. So close price in US dollar and days. So you can see that this orange line you can see. Okay, this is the basically original value. Okay, you can see this is the original value, and which is the blue. This is actual value. Okay, and last, which is in I say this is purple. This is the predicted value according to the data set, our data set. So this is the predicted value. Okay, so this is, I hope you understand it. uh, this is the first, this is the bar graph. You can see actual and predicted, and last, which I had showed you, this is a line graph which shows the which shows our original value and actual value and predicted value. So thank you, I hope you understand.